Okay, so good day. This will be your first activity. So watch this video presentation. Then after this video presentation, you are required to submit your learnings.
how it's done, who's using it, and then we'll discuss a few challenges and tips that I picked up along the way that I'd be happy to share with you. Okay, so first, what is business analytics? So business analytics involves using tools and techniques to turn data into meaningful business insights. So it's using tools and techniques to turn data into meaningful business insights. So that data could be from spreadsheets or from traditional databases. It could also be from Twitter or from Facebook. And then we're using tools and techniques. The techniques might be statistical models or machine learning, something. And then the hope at the end of the day is that we get some business insights out of it. Now, if you look at this diagram, it looks pretty straightforward, right? But I don't think this does a good job of communicating the complexity of analytics. I sometimes, it sort of feels like this to me. So we get some good data coming in. We also get a lot of messy data that we have to scrub and clean up to make usable. And we also get a lot of garbage data along the way that just isn't really helpful at all. And then we kind of have to fight with the data, battle with it, to get something out of it. It just, sometimes it becomes a spaghetti mess, it feels like. And then because we have, garbage data or messy data coming in, sometimes on the other end, we do get some business insights. We also get a lot of noise that comes out. And sometimes if we're not careful, and that noise or that garbage that comes out gets used to make decisions, it can be harmful, right? So this, I think, does a better job of communicating some of the challenges that are faced when on analytics projects. Okay, so now let's talk about the types of analytics. There's descriptive analytics, which deals with what happened, right? So we're looking at historical information to maybe piece a puzzle together. An example might be we're looking at data from the previous quarter, our sales data, for example, and maybe comparing that data to the same quarter in the previous year. So we're trying to figure out what happened. And then there's predictive analytics. So that's trying to figure out what might happen. So we might use statistical models to do that. And then there's prescriptive analytics. So that actually involves telling us what we should do. So to get there, we might even use some of the descriptive analytics or the predictive analytics to then get to a prescription, right? We might recommend decisions based on some optimization models that we put together or some simulations, that sort of thing. In my opinion, I think all of these are important and they have their place, but as we go down this list, it gets more value added. I think that the best type of analytics are prescriptive analytics, in my opinion. Okay, just want to talk for a second about some buzzwords. So you've probably heard some things similar to business analytics, business intelligence, decision science, data science. I don't want you to worry too much about it. They all really support the same goal, and it's true, there may be some slight differences, but all they're trying to get to the same end, right? It involves using tools and techniques to turn data into business insights, right? All of those help us get to that end state. Okay, so now we want to talk a little bit about the process, right? How we do analytics. What's the method? What are the methods that we use? So similar to the scientific method, we always start with a business problem that we're trying to solve. Some of the problems might be, how do we optimize pricing? What's the optimal price to allow us to boost our revenue? Or how might we segment our customers to tailor product offers to them so there's a higher likelihood that they'll buy something? Or a problem might be solving bottlenecks or failure points in our supply chain. So we first want to figure out what problem we're trying to solve. The next thing we'll want to do is to plan the work. So we do some research on the problem. We maybe estimate the effort that's required to do the analytics on it, and then we'll build a business case to get support from our leadership or whoever's asking us to do this. And I know sometimes in the excitement of doing the analytics, we can sometimes skip this step, but I think it's important not to neglect it. It certainly doesn't have to take a long time to do this. A lot of this can be done in a couple hours, but I think it's still important that you don't make any commitments to do something until you've kind of figured out first if it's even possible, and then how much effort and money is going to be required to do that. So some of the things that we might want to ask about the data that we're needing is first, is it available? Can we even get to the data? And if we can, what's the quality of the data? If it's garbage and we're not going to be able to clean it up, and that's going to be a problem. And if it's messy, we still got to spend time to scrub it, so that's something that we need to be aware of. Another thing we might want to ask, is it granular enough? So if we're looking for sales data at the city level, for example, if we can only get it at the state level or the country level, that could be a problem. So those are some of the things that we want to think about before we get started, right? I think it'll save you a lot of pain later if you've gone through this type of research and this level of planning. Now, once we've done that, we want to put a business case together. This doesn't have to be complicated at all. It can be very simple. But what we're trying to do is to communicate to our leadership, or whoever asks us to do the analytics, how much it's going to cost, and based on the costs, what are the benefits that we're going to get out of it. And I like to couch these in terms of good, better, and best options. You certainly can make a recommendation on which one might be most appropriate, or what's the best use of money, but it's always nice to give people a couple different options. I don't know, I just think it adds a little bit of value. And then obviously, once we've shared this with our leadership, we don't want to move forward until we have their strong support, right? We don't want to make any investments until we get their buy-in, their approval. Okay, so now once we've identified the problem, planned out how we can solve it, and gotten, did some analysis or estimated what the cost might be and what benefit we might get for those costs, then, assuming we've got the approval, we can start getting to work. So what we want to look at doing is grabbing the data that we need, finding a place to store it. We'll want to spend some time cleaning it and scrubbing it, analyzing it and maybe visualizing it, and then interpreting it, right? In the end, we want to get those insights out of it. Some of these may happen in parallel, and that's okay, or some may be switched around in some cases, but you get the idea. Again, we're grabbing the data, we're storing it somewhere, cleaning it to get into the format that we need, and then doing the analysis and maybe some visualizations, and then interpreting what we get out of that to get those insights. Okay, so next, I want to just share with you some sample architectures. So how does this look technically? And this doesn't cover, every way that analytics is done. It's just some of the more common examples that I've seen. There's a million possibilities and permutations of this, but this just kind of gives you some ideas of some of the more common approaches that are taken. The first architecture example that I see a lot actually is what I call traditional analytics. So this is for big structured implementations. It supports lots of demand, but sometimes it can be stiff. And it's designed that way, right? So there's some governance in place to make sure that the data stays of good quality and that it's secure, and so only people that see the data should see the data and that sort of thing. So it's designed to be a little bit stiff, and so it can be more difficult to respond, but we do that because we need some level of control, some level of governance, right? So in this example, we're going to pull data from transactional systems, so data that's coming from our supply chain, maybe from points of sale systems, from finance data that maybe eventually gets reported to Wall Street. So we're pulling data from transactional systems using ETL. So this means extracting the data, transforming it, getting it into the format we need, and then loading it. We're going to load it into what we call our data warehouse. That's our reporting repository. That's where we're going to store our reporting data. And then what we'll do is we will point our tools, right, our analytics tools on the front end. This could be Microsoft Excel in some cases, or it could be some of the new flashier tools like Tableau or QlikView. We point it to that data to then generate graphs or models or whatever it may be. Okay, another example is what I call big data analytics. I'm starting to see this more frequently. So this is for big unstructured implementations. It supports lots of demand, and it can support lots of demand really fast, right? So in this example, we might be pulling data from Twitter, from Facebook, from the web, maybe from message boards or sites or something. And we're pulling that data into a Hadoop cluster. We won't go into Hadoop here, but it's talked a lot about when we discuss big data. But Hadoop allows you to ingest lots of amount of data really fast, lots of unstructured data. And it also allows you to do some scrubbing on that huge data set that might be really difficult to do in a more traditional environment. And a cluster is just kind of a collection of computers that are working together. So they're all working together to analyze this unstructured data. And then we're pulling that data, in some cases, at least a subset of that data that we've maybe now structured, or we've cleaned up, we've scrubbed, into our data warehouse, which we talked about in the previous example. This is like a reporting repository, right? And again, we're pointing some of our tools on the front end, whatever it may be, Tableau, QlikView, Microsoft Excel, we're pointing that to our data warehouse. My guess is that we'll see models like this more and more often as the volume of data that comes in continues to grow, and as we see more unstructured data coming in. Another example is what I call the Excel power user. I don't want to dismiss this at all, because this actually happens a lot. It still can be analytics, right? Even though we may not think of it that way. So this model is affordable, but it may only be for a limited number of users, but it does allow you to respond to needs really fast. So an example might be maybe your boss needs you to, pull in some data from several spreadsheets or from Microsoft Access database that they have somewhere, and maybe a little bit of data from the web. I want you to do some research, analysis, try to solve a business problem that you can do in Excel. Excel allows you to do it. It's not a huge data set, and you can easily, when you're done, when you've done ran your pivot tables or built your statistical models in Excel, or you can even do optimization in Excel too. Once you've done that, all you have to do is then email out the file, share your findings, and be done with it. I see this a lot, and it's still certainly can be analytics. Okay, now I want to look at a case study that I really like from Capital One. Now, they're not the only one that does this, but they're one of the first people to try it out. So what they did was take publicly available credit and demographic data. So this is data that you could get off the web, right, or wherever, right? And they figure out and build models to determine how to segment customers, and then what products to tailor to them. So based on someone's demographics, where they live and how much income they make or their credit history, based on historical data, they can figure out what those types of people bought and then tailor future offers to new customers. So in this case, what happens is, as a customer calls in, or as they call a customer, right before that customer even says hello, that model's running in the background against that customer's information, and they're figuring out, okay, based on what we saw in the past, And based upon who this customer is, we think they are most likely to buy this type of product, and we ought to offer them this type of credit limit. And what's interesting in this model is that it was able to predict what a caller might want to buy with greater than 70% accuracy. That's huge. So you're not just taking this really broad approach, right? You're tailoring offers, very specific offers, to certain types of customers. A really cool example. There's a million others. This is just one example that I really like. Okay, now we want to talk about some of the challenges that you might face. The first is that data often needs a lot of cleaning. We've talked about this a little bit already. But what I found is sometimes it's not so much the analysis that's difficult. It's actually getting the data ready, cleaning it and scrubbing it, and getting it in a format where you can do that analysis. This can sometimes be the most frustrating part of it, right? Just having to clean the data to get it ready. Another challenge is that data is getting much more unstructured. So it doesn't all come from relational databases or from spreadsheets. We could be getting PDFs, music files, pictures, movies. We even talked about data that's coming in from Twitter or from Facebook. It's getting much more challenging, right? It's in a variety of different formats. And to add to that, data volumes are growing much faster. So not only is the data, a lot of it messy, it's coming in a variety of formats, and it's coming really fast. Traditional models, like ones that we mentioned, are having difficulty handling that. I like this quote from IBM. 90% of the data in the world today has been created in the last 2 years. It's just going to continue to grow at pretty alarming rates. And so on top of all this, what we need to keep in mind as well is that markets are becoming more competitive, right? It's demanding decisions faster if we want to stay competitive. So not only do we have more difficult data and more data to work with, we've also got to be able to, produce insights at a faster rate in order to compete. Another challenge, good analytics doesn't always solve bad business process. So if we have a process that's producing poor data that we're using for our analytics, the insights that come out of that might be meaningless or even harmful if we use them to make important decisions. So if we have garbage coming in, we might have garbage coming out. The only silver lining to this is that based on the garbage that comes out, you might then realize that you've got to make some adjustments to how you're collecting data on the process. That's the only silver lining that you might want to think about. Okay, just as far as a couple tips go, the first one that I think you ought to keep in mind is that you always ought to be providing recommendations and not just data or information, right? So we get insights that come out and we can use those to help provide recommendations to our business. Anyone can just summarize and graph data in Excel or generate some pivot tables maybe, but real value comes when you can provide actionable recommendations to your business. So obviously supported by that data that you've analyzed. Another tip, and this is becoming more important, I see this come up more frequently, is that you ought to allow your business more freedom to explore the data that you bring in. A lot of our business partners are becoming very tech savvy and they want to do some analysis on their own, right? It used to be that a lot of this work was done in silos, so you had database administrators and maybe statisticians, and the business wasn't as actively involved, but they want to be involved, right? They want to be able to do the analysis. Where we can come in is by providing them some guidance and some governance, just so it's not the wild, wild west, right? And the retrieval tools that they can use to make discoveries on their own. Another tip is to not dismiss expert advice or your gut. So some people think that analytics might eliminate the need for expertise, right? Or experience. But in a lot of cases, they can support each other or supplement each other or confirm each other. So they can work together really well. It doesn't have to be one or the other. Another tip, you should break problems down into smaller pieces and deliver data insights more often. So you don't have to solve the entire problem before you start sharing some of this information. You can build excitement as you start sharing some of the insights that come out. And if we wait too long to share information, it might be too late to make an optimal decision. Another tip, keep a data dictionary. This is just something that describes your data. It talks about the database tables that you have, the database schemas or the sources that you're pulling from, the fields in the tables and the database keys, the data types, the frequency with which you get the data, the granularity, how it's being loaded. And this will help other people who come after you, right, who are looking to solve business problems and don't realize that maybe the data is already available. And so they may just need to look at your data dictionary to figure out if it fulfills their requirements. Another tip, don't get too rigid with your architecture. So we talk about how data is becoming more complex. It's much more unstructured. It's coming at a faster rate. And we have to have a variety of tools to be able to handle some of this. So it's not that, hammer is just not going to work. It's got to be a toolbox, right? Several things that we may need to use. And sometimes the tool that we use depends on the type of problem we're trying.
Today, I will talk about big data analytics. Before I start off, I'll first run you through the different topics I will be covering in this video. I'll first start off with why big data analytics is required. It is a must that we should understand why it is needed before understanding what big data analytics is. I will then move on to its life cycle, the various types of big data analytics, the numerous tools used to achieve it, and finally, I will look into various application domains. Let us now understand why big data analytics is required with an example. So all of you listen to music online, isn't it? Here we will take an example of Spotify, which is a Swedish audio streaming platform, and see how big data analytics is used here. Spotify has nearly 96 plus million users, and all these users generate a tremendous amount of data. Data like the songs which are played repeatedly, the numerous likes, shares, and the user's search history. All these data can be termed as big data here with respect to Spotify. Have you ever wondered what Spotify does with all this big data? Well, Spotify analyzes this big data for suggesting songs to its users. I'm sure all of you might have come across the recommendation list which is made available to each one of you by Spotify. Each one of you will have a totally different recommendation list. This is based on your likes, your past history, like the songs you like listening to, and your playlists. This works on something known as the recommendation system. Recommendation systems are nothing but data filtering tools. They collect all the data and then filter them using various algorithms. This system has the ability to accurately predict what a user would like to listen to next with the help of big data analytics. This prediction helps the users stay on the page for a longer time, and by doing so, Spotify engages all its users. The users don't have the need to go on searching for different songs. This is because Spotify readily provides them with a variety of songs according to their taste. Well, this is how big data analytics is used by Spotify. Now that we have understood why big data analytics is required, let us move on to our next topic, that is, what is big data analytics? But before that, there is another term we need to understand, that is big data. We all hear the term big data many a times, but do you know what exactly big data means? Well, we will understand the term big data clearly right now. Big data is a term for data sets that cannot be handled by traditional computers or tools due to their value, volume, velocity, and veracity. It is defined as massive amount of data which cannot be stored, processed, and analyzed using various traditional methods. Do you know how much data is being generated every day, every second? Even as I talk right now, there are millions of data sources which generate data at a very rapid rate. These data sources are present across the world. As you know, social media sites generate a lot of data. Let's take an example of Facebook. Facebook generates over 500 plus terabytes of data every day. This data is mainly generated in terms of your photographs, videos, messages, etc. Big data also contains data of different formats like structured data, semi-structured data, and unstructured data. Data like your Excel sheets all fall under structured data. This data has a definite format. Your emails fall under semi-structured and your pictures and videos all fall under unstructured data. All this data together make up for big data. It is very tough to store, process, and analyze big data using RDBMS. If you have looked into our previous videos, you would know that Hadoop is the solution to this. Hadoop is a framework that stores and processes big data. It stores big data using the distributed storage system and it processes big data using the parallel processing method. Hence, storing and processing big data is no more a problem using Hadoop. Big data in its raw form is of no use to us. We must try to derive meaningful information from it in order to benefit from this big data. Do you know Amazon uses big data to monitor its items that are in its fulfillment centers across the globe? How do you think Amazon does this? Well, it is done by analyzing big data, which is known as big data analytics. What is big data analytics? In simple terms, big data analytics is defined as the process which is used to extract meaningful information from big data. This information could be your hidden patterns, unknown correlations, market trends, and so on. By using big data analytics, there are many advantages. It can be used for better decision making, to prevent fraudulent activities, and many others. We will look into 4 of them step by step. I will first start off with big data analytics, which is used for risk management. BDO, which is a Philippine banking company, uses big data analytics for risk management. Risk management is an important aspect for any organization, especially in the field of banking. Risk management analysis comprises a series of measures which are employed to prevent any sort of unauthorized activities. Identifying fraudulent activities was a main concern for BDO. It was difficult for the bank to identify the fraudster from a long list of suspects. BDO adopted big data analytics, which helped the bank to narrow down the entire list of suspects. Thus, the organization was able to identify the fraudster in a very short time. This is how big data analytics is used in the field of banking for risk management. Let us now see how big data analytics is used for product development and innovations with an example. All of you are aware of Rolls-Royce cars, right? Do you also know that they manufacture jet engines which are used across the world? What is more interesting is that they use big data analytics for developing and innovating this engine. A new product is always developed by trial and error method. Big data analytics is used here to analyze if an engine design is good or bad. It is also used to analyze if there can be more scope for improvement based on the previous models and on the future demands. This way, big data analytics is used in designing a product which is of higher quality. Using big data analytics, the company can save a lot of time. If the team is struggling to arrive at the right conclusion, big data can be used to zero in on the right data which have to be studied, and thus the time spent on the product development is less. Big data analytics helps in quicker and better decision making in organizations. The process of selecting a course of action from various other alternatives is known as decision making. Lot of organizations take important decisions based on the data that they have. Data-driven business decisions can make or break a company. Hence, it is important to analyze all the possibilities thoroughly and quickly before making important decisions. Let us now try to understand this with an use case. Starbucks uses big data analytics for making important decisions. They decide the location of their new outlet using big data analytics. Choosing the right location is an important factor for any organization. The wrong location will not be able to attract the required amount of customers. Positioning of a new outlet a few miles here or there can always make a huge difference for an outlet, especially a one like Starbucks. Various factors are involved in choosing the right location for a new outlet. For example, parking adequacy has to be taken into consideration. It would be inconvenient for people to go to a store which has no parking facility. Similarly, the other factors that have to be considered are the visibility of the location, the accessibility, the economic factors, the population of that particular location, and also we would have to look into the competition in the vicinity. All these factors have to be thoroughly analyzed before making a decision as to where the new outlet must be started. Without analyzing these factors, it would be impossible for us to make a wise decision. Using big data analytics, we can consider all these factors and analyze them quickly and thoroughly. Thus, Starbucks makes use of big data analytics to understand if their new location would be fruitful or not. Finally, we will look into how big data analytics is used to improve customer experience using an example. Delta, an American airline, uses big data analytics to improve its customer experiences. With the increase in global air travel, it is necessary that an airline does everything they can in order to provide good service and experience to its customers. Delta Airlines improves its customer experience by making use of big data analytics. This is done by monitoring tweets, which will give them an idea as to how their customer's journey was. If the airline comes across a negative tweet and if it is found to be the airline's fault, the airline goes ahead and upgrades that particular customer's ticket. When this happens, the customer is able to trust the airlines, and without a doubt, the customer will choose Delta for their next journey. By doing so, the customer is happy and the airlines will be able to build a good brand recognition. Thus, we see here that by using analysis, Delta Airlines was able to improve its customer experience. Moving on to our next topic, that is life cycle of big data analytics. Here we will look into the various stages as to how data is analyzed from scratch. The first stage is the business case evaluation stage. Here, the motive behind the analysis is identified. We need to understand why we are analyzing so that we know how to do it and what are the different parameters that have to be looked into. Once this is done, it is clear for us and it becomes much easier for us to proceed with the rest. After which, we will look into the various data sources from where we can gather all the data which will be required for analysis. Once we get the required data, we will have to see if the data that we received is fit for analysis or not. Not all the data that we receive will have meaningful information. Some of it will surely just be corrupt data. To remove this corrupt data, we will pass this entire data through a filtering stage. In this stage, all the corrupt data will be removed. Now we have the data minus the corrupt data. Do you think our data is now fit for analysis? Well, it is not. We still have to figure out which data will be compatible with the tool that we will be using for analysis. If we find data which is incompatible, we first extract it and then transform it to a compatible form depending on the tool that we use. In the next stage, all the data with the same fields will be integrated. This is known as the data aggregation stage. The next stage, which is the analysis stage, is a very important stage in the life cycle of big data analytics. Right here in this step, the entire process of evaluating your data using various analytical and statistical tools to discover meaningful information is done. Like we've discussed before, the entire process of deriving meaningful information from data, which is known as analysis, is done here in this stage. The result of the data analysis stage is then graphically communicated using tools like Tableau, Power BI, ClickView. This analysis result will then be made available to different business stakeholders for various decision making. This was the entire life cycle of big data analytics. We just saw how data is analyzed from scratch. Now we will move on to a very important topic, that is the different types of big data analytics. Well, we have 4 different types of big data analytics. As you see here, these are the types, and below this are the questions that each type tries to answer. We have descriptive analytics, which asks the question, what has happened? Then we have diagnostic analytics, which asks, why did it happen? Predictive analytics, asking what will happen? And prescriptive analytics, which questions by asking what is the solution. We will look into all these 4 one by one with an use case for each. We will first start off with descriptive analytics. As mentioned earlier, descriptive analytics asks the question, what has happened? It can be defined as the type that summarizes past data into a form that can be understood by humans. In this type, we will look into the past data and arrive at various conclusions. For example, an organization can review its performance using descriptive analytics. That is, it analyzes its past data such as revenue over the years and arrives at a conclusion with the profit. By looking at this graph, we can understand if the company is running at a profit or not. Thus, descriptive analytics helps us understand this easily. We can simply say that descriptive analytics is used for creating various reports for companies and also for tabulating various social media metrics like Facebook likes, tweets, etc. Now that we have seen what is descriptive analytics, let us look into an use case of descriptive analytics. The Dow Chemical Company analyzed all its past data using descriptive analytics, and by doing so, they were able to identify the underutilized space in their facility. Descriptive analytics helped them in this space consolidation. On the whole, the company was able to save nearly $4 million annually. So we now see here that descriptive analytics not only helps us derive meaningful information from the past data, but it can also help companies in cost reduction if it is used wisely. Let us now move on to our next type, that is diagnostic analytics. Diagnostic analytics asks the question why a particular problem has occurred. As you can see, it will always ask the question, why did it happen? It will look into the root cause of a problem and try to understand why it has occurred. Diagnostic analytics makes use of various techniques such as data mining, data discovery, and drill down. Companies benefit from this type of analytics because it helps them look into the root cause of a problem. By doing so, the next time the same problem will not arise, as the company already knows why it has happened and they will arrive at a particular solution for it. iNetSoft's BI query tool is an example of diagnostic analytics. We can use query tool for diagnostic analytics. Now that you know why diagnostic analytics is required and what diagnostic analytics is, I will run you through an example which shows where diagnostic analytics can be used. All of us shop on e-commerce sites, right? Have you ever added items to your cart but ended up not buying it? Yes, all of us might have done that at some point. An organization tries to understand why its customers don't end up buying their products although it has been added to their carts. And this understanding is done with the help of diagnostic analytics. An e-commerce site wonders why they have made few online sales although they have had a very good marketing strategy. There could have been various factors as to why this has happened. Factors like the shipping fee which was too high, or the page that didn't load correctly, not enough payment options available, and so on. All these factors are analyzed using diagnostic analytics and the company comes to a conclusion as to why this has happened. Thus, we see here that the root cause is identified so that in future the same problem doesn't occur again. Let us now move on to the third type, that is predictive analytics. As the name suggests, predictive analytics makes predictions of the future. It analyzes the current and historical facts to make predictions about future. It always asks the question, what will happen next? Predictive analytics is used with the help of artificial intelligence, machine learning, data mining to analyze the data. It can be used for predicting customer trends, market trends, customer behavior, etc. It solely works on probability. It always tries to understand what can happen next with the help of all the past and current information. A company like PayPal, which has 260 plus million accounts, always has the need to ensure that their online fraudulent and unauthorized activities are brought down to nil. Fear of constant fraudulent activities have always been a major concern for PayPal. When a fraudulent activity occurs, people lose trust in the company, and this brings in a very bad name for the brand. It is inevitable that fraudulent activities will happen in a company like PayPal, which is one of the largest online payment processors in the world. But PayPal uses analytics wisely here to prevent such fraudulent activities and to minimize them. It uses predictive analytics to do so. The organization is able to analyze past data, which includes a customer's historical payment data, a customer's behavior trend, and then it builds an algorithm which works on predicting what is likely to happen next with respect to their transaction. With the use of big data and algorithms, the system can gauge which of the transactions are valid and which could be potentially a fraudulent activity. By doing so, PayPal is always ready with precautions that they have to take to protect all their clients against fraudulent transactions. We will now move on to our last type, that is prescriptive analytics. Prescriptive analytics, as the name suggests, always prescribes a solution to a particular problem. The problem can be something which is happening currently. Hence, it can be termed as the type that always asks the question, what is the solution? Prescriptive analytics is related to both predictive and descriptive analytics. As we saw earlier, descriptive analytics always asks the question, what has happened? And predictive analytics helps you understand what can happen next. With the help of artificial intelligence and machine learning, prescriptive analytics helps you arrive at the best solution for a particular problem. Various business rules, algorithms, and computational modeling procedures are used in prescriptive analytics. Let us now have a look at how and where prescriptive analytics is used with an example. Here we will understand how prescriptive analytics is used by an airline for its profit. Do you know that when you book a flight ticket, the price of it depends on various factors, both internal and external factors. Apart from taxes, seat selection, there are other factors like oil prices, customer demand, which are all taken into consideration before the flight's fare is displayed. Prices change due to availability and demand. Holiday seasons are a time when the rates are much higher than the normal days. Seasons like Christmas and school vacations, also weekends, the rates will be much higher than weekdays. Another factor which determines a flight's fare is your destination. Depending on the place where you are traveling to, the flight fare will be adjusted accordingly. This is because there are quite a few places where the air traffic is less, and in such places the flight's fare will also be less. So prescriptive analytics analyzes all these factors that are discussed, and it builds an algorithm which will automatically adjust a flight's fare. By doing so, the airline is able to maximize its profit. These were the 4 types of analytics. Now let us understand how we achieve these with the use of big data tools. Our next topic will be the various tools used in big data analytics. These are a few of the tools that I will be talking about today. We have Hadoop, MongoDB, Talend, Kafka, Cassandra, Spark, and Storm. We will look into each one of them one by one. We will first start off with Hadoop. When you speak of big data, the first framework that comes into everyone's mind is Hadoop, isn't it? As I mentioned earlier, Apache Hadoop is used to store and process big data in a distributed and parallel fashion. It allows us to process data very fast. Hadoop uses MapReduce, Pig, and Hive for analyzing using this big data. Hadoop is easily one of the most famous big data tools. Now let us move on to the next one, that is MongoDB. MongoDB is a cross-platform document-oriented database. It has the ability to deal with large amount of unstructured data, processing of data which is unstructured, and processing of data sets that change very frequently is done using MongoDB. Talend provides software and services for data integration, data management, and cloud storage. It specializes in big data integration. Talend Open Studio is a free open source tool for processing data easily on a big data environment. Cassandra is used widely for an effective management of large amounts of data. It is similar to Hadoop in its feature of fault tolerance, where data is automatically replicated to multiple nodes. Cassandra is preferred for real-time processing. Spark is another tool that is used for data processing. This data processing engine is developed to process data way faster than Hadoop MapReduce. This is done in a way because Spark does all the processing in the main memory of the data nodes, and thus it prevents unnecessary input-output overheads with the disk. Whereas MapReduce is disk-based, and hence Spark proves to be faster than Hadoop MapReduce. Storm is a free big data computational system which is done in real time. It is one of the easiest tools for big data analysis. It can be used with any programming language. This feature makes Storm very simple to use. Finally, we will look into another big data tool which is known as Kafka. Kafka is a distributed streaming platform which was developed by LinkedIn and later given to Apache Software Foundation. It is used to provide real-time analytics result, and it is also used for fault-tolerant storage. These were few of the big data analytics tools. Now let us move on to our last topic for today, that is big data application domains. Here we will look into the various sectors where big data analytics is actively used. The first sector is e-commerce. Nearly 45% of the world is online, and they create a lot of data every second. Big data can be used smartly in the field of e-commerce by predicting customer trend, forecasting demands, adjusting the price, and so on. Online retailers have the opportunity to create better shopping experience and generate higher sales if big data analytics is used correctly. Having big data doesn't automatically lead to a better marketing strategy. Meaningful insights need to be derived from it in order to make right decisions. By analyzing big data, we can have personalized marketing campaigns, which can result in better and higher sales. In the field of education, depending on the market requirements, new courses are developed. The market requirement needs to be analyzed correctly with respect to the scope of a course, and accordingly a scope needs to be developed. There is no point in developing a course which has no scope in the future. Hence, to analyze the market requirement and to develop new courses, we use big data analytics here. There are a number of uses of big data analytics in the field of healthcare, and one of it is to predict a patient's health issue. That is, with the help of their previous medical history, big data analytics can determine how likely they are to have a particular health issue in the future. The example of Spotify that we saw previously showed how big data analytics is used to provide a personalized recommendation list to all its users. Similarly, in the field of media and entertainment, big data analytics is used to understand the demands of shows, songs, movies, and so on to deliver personalized recommendation lists, as we saw with Spotify. Big data analytics is used in the field of banking. As we saw previously with a few use cases, big data analytics was used for risk management. In addition to risk management, it is also used to analyze a customer's income and spend patterns and to help the bank predict if a particular customer is going to choose any of the bank offers such as loans, credit cards, schemes, and so on. This way, the bank is able to identify the right customer who is interested in its offers. It is noticed that telecom companies have begun to embrace big data to gain profit. Big data analytics helps in analyzing network traffic and call data records. It can also improve its service quality and improve its customer experience experience. Let us now look into how big data analytics is used by governments across the world. In the field of law enforcement, big data analytics can be applied to analyze all the available data to understand crime patterns. Intelligence services can use predictive analytics to forecast the crime which could be committed. In Durham, the police department was able to reduce the crime rate using big data analytics. With the help of data, police could identify whom to target, where to go, when to patrol, and how to investigate crimes. Big data analytics helped them to discover patterns of crime emerging in the area. Now that we have seen the various sectors where big data analytics is used, let us quickly try to recollect everything that we have seen in this video. We started off with why big data analytics is necessary with an example of Spotify. We then moved on to what is big data and what is big data analytics. We also saw the various sectors big data analytics is used with an example for each. We then looked into its life cycle, the various types of big data analytics with an example for each. We later looked into the tools used to achieve it. And finally, we looked into the various application domains. And this brings us to the end of this tutorial.
Data and business analytics. Big data consists of huge amount of diverse data that arrives in increasing volumes and with ever higher velocity. Also, big data can be structured data in numeric and formatted forms as well as unstructured data which are less quantifiable and in free form. There are 5 V's in big data. They are volume, velocity, variety, veracity, and variability. 1. Volume. The amount of data produced is very huge. For example, in petabytes, 1 PB equals 10 to the power of 15 bytes, and zettabytes, 1 ZB equals 10 to the power of 21 bytes. 2. Velocity, speed at which data is created, captured, and streamed, for example, real-time streaming data. 3. Variety, data comes in many different formats, for example, structured data, semi-structured data, unstructured data. 4. Veracity, analysis performed on data would be more useful when data quality is improved. 5. Variability, data changes during processing and life cycle. Also, there are additional V's, including 6. Value, 7. Visualization, 8. Viability, 9. Validity, 10. Venue, 11. Vocabulary and 12. Vagueness. In short, these V's describe valuable big data. Big data enable managers to solve problems analytically by using business analytics. 1. What is happening in the business? Accurate, comprehensive, and live data can be found using descriptive analytics. Managers can investigate the issues by using data visualization. Managerial dashboard is commonly using to monitor the key performance indicators. 2. What is it happening? Managers can drill down the root cause and isolate all confounding information. Diagnostic analytics help them to understand the issues more clearly. 3. What is likely to happen? Historical patterns are being used to predict specific outcomes, and predictive analytics can be performed to estimate future events. By setting right business strategies, managers can perform forecasting powered by algorithms. 4. What do the business need to do? Prescriptive analytics facilitate managers to review recommended actions and strategies by optimizing the decision. Moreover, managers can perform simulation to determine the best decision with the applications of computational tools. Companies and organizations use big data to generate revenues and understand more about preference of their customers or clients. They can promote their products and services by placing targeted ads on selected promotional channels such as social media and attracted interested parties to serve their web pages.
Okay, this will be actually the required readings, no, and I think required activity and document as presented in our course syllabus.
Good day everyone. In today's video, we will be discussing business analytics and big data. Here are the topics to be discussed. Let us first define analytics. Analytics is the scientific process of discovering and communicating the meaningful patterns which can be found in data. It is concerned with turning raw data into insight for making better decisions. Analytics relies on the application of statistics, computer programming, and operations research in order to quantify and gain insights to the meanings of data. It is especially useful in areas which record a lot of data or information. What is business analytics? Business analytics is the iterative methodical exploration of an organization's data with an emphasis of statistical analysis. Business analytics is used to or by companies that use data-driven decision making. Once the business goal of the analysis is determined, an analysis methodology is selected, and business data is required to support the analysis. Data acquisition often involves extraction from multiple business systems and data sources. Then, cleansing and integrating data into a single repository, such as a data warehouse or data mart. There are four fundamental types of business analytics: descriptive analytics, diagnostic analytics, predictive, and prescriptive analytics. Descriptive analytics tells us what happened, which describes how things have changed over time. Diagnostic analytics thus as our answers the question, why did it happen, which focuses or it focuses on the explanation of an event's occurrence. It necessitates hypothesizing and utilizes a large and diverse data set. In predictive analytics, it answers the question, what could happen in the future? It focuses on incidents that are likely to happen in the near future. And lastly, we have the prescriptive analytics, which answers the question, how should we respond to those potential future events? This indicates that there is a strategy in place. So, what are the functions of these types of business analytics? Let us first discuss descriptive analytics. To discover historical data, prescriptive analytics employs two main methods: data aggregation and data mining, also known as data discovery. The process of gathering and arranging data to create manageable datasets is known as data aggregation. These datasets are then used in the data mining process, which identifies patterns, trends, and context before being presented in a comprehensible manner. Remember that descriptive analytics does not seek to go beyond the surface data and analysis. Further research is beyond the scope of descriptive analytics, and descriptive analytics observations are not used to make inferences or predictions. What information is derived from descriptive analytics? Descriptive analytics can provide us reports for inventory, workflow, sales, and revenue. It can also provide us social analytics like average number of replies per post, number of page views, average response time, and attitudes. The next type is predictive analytics. Predictive analytics is a form of advanced analytics that uses both new and historical data to forecast behavior and trends. It involves constructing predictive models that assign a numerical value or ranking to the likelihood of a particular event occurring using statistical analysis techniques, analytical questions, and automated machine learning algorithms. So, how does predictive analytics work? Probabilities are used in predictive analytics. Predictive analytics aims to forecast potential future outcomes and the probability of those events using a range of techniques, including data mining, statistical modeling, machine learning algorithms. Now, machine learning algorithms, for example, take existing data and try to fill in the gaps, which the best or with the best possible guesses in order to make predictions. So, what are the information that we can derive from predictive analytics? Predictive analytics allows executives and managers to make a more strategic, data driven approach to business planning and decision making because it can tell them what will happen in the future. Predictive analytics may be used for a variety of purposes, including predicting consumer behavior and buying habits, as well as detecting sales trends. Predictions can also help with supply chain, processes, and inventory demand forecasting. Lastly, we have prescriptive analytics. Prescriptive analytics is used to determine the best outcome of or to events given the parameters and to propose decision strategies for taking advantage of potential opportunities or mitigating future risk. This method is the third, final, and most advanced stage in the business analysis process and the one that calls business to action, helping executives, managers, and operational employees make the best possible decisions based on the data available to them. So, how does prescriptive analytics works? Now, prescriptive analytics expands on what has been learned through descriptive and predictive analysis by proposing the best possible courses of action for a business. A variety of techniques and methods, such as guidelines, statistics, and machine learning algorithms, can be applied to available data from both internal and external data in order to make predictions and recommendations. Machine learning's capabilities far exceeds what a person would do while attempting to achieve the same performance. The following are information that can be derived from prescriptive analytics. Make recommendations in regard to which decisions will best take advance of future opportunities or mitigate future risk. Another is make it possible to consider the possible outcomes for each before any decisions are made and can have a real impact on business strategy and decision making to improve things such as production, consumer experience, and business growth. We now go to our second topic, which is big data. Let us first define big data. Big data is a collection of structured, semi structured, and unstructured data collected by organizations and used for information mining, machine learning projects, predictive modeling, and other advanced analytics applications. Big data is a massive collection of data that is growing exponentially over time. It is a data set that is so large and complex that traditional data management tools cannot store or process it efficiently. Big data is a type of data that is extremely large in size. Here are some examples of big data. First, we have the New York Stock Exchange. Now, the New York Stock Exchange generates about 1 terabyte of new trade data per day. Another is the statistics shows that 500 terabytes or 500 plus terabytes of new data get ingested into the database of social media sites like Facebook every day. This data is mainly generated in terms of photos and video uploads, message exchanges, and putting comments. Another example is a single jet engine. A single jet engine can generate 10 plus, okay, terabytes of data in 30 minutes of flight time. With many thousand flights per day, generation of data reaches up to petabytes. So what are the different types of big data? As we have mentioned earlier, we have structured, unstructured, and semi-structured. Now, structured data is defined as any data that can be stored, accessed, and processed in a fixed format. Unstructured data is defined as any data with an unknown form or structure. And lastly, we have the semi-structured. Now, semi-structured is both types of data that can be found in a semi-structured data. Semi-structured data appears to be structured, but it is not defined in the same way that a table definition in a rational database management system is. So, what are the characteristics of big data? So, we have four characteristics of big data: volume, variety, velocity, and variability. Now, volume, the term big data refers to a massive amount of information. The size of the data is very important in determining the value of the data. Furthermore, whether a particular data set can be considered big data or not is determined by the volume of data. As a result, volume is one of the characteristics that must be considered when dealing with big data. The second characteristic is variety. Now, variety is the next feature of big data, which is diverse. The term variety refers to a wide range of data sources and data types, both structured and unstructured. Previously, spreadsheets and databases were the only data sources considered by most applications. The next is velocity. The term velocity refers to the rate at which data is generated. The true potential of the data is determined by how quickly it is generated and processed to meet the demands. Big data velocity is concerned with the rate at which data is ingested from sources such as business processes, application logs, networks, and social media sites, sensors, mobile devices, and so on. The data flow is massive and continuous. Lastly, we have variability. Now, variability refers to the inconsistency that data can exhibit at times, impeding the process of effective handling and managing data. And that concludes this video.
And welcome to Knowledge Hut. In this video, let's learn about what big data is and how it's classified. Let us begin by defining the term data. If you do a quick Google search, then you will find that data is defined as the qualities, characters, or symbols on which operations are performed by a computer, which may be stored and transmitted in the form of electrical signals and recorded on magnetic, optical, or mechanical recording media. In simple words, we can say that all the facts and figures which can be stored in digital format can be termed as data. All the text, numbers, images, audios, videos stored in our phones and computers are some examples of data. They are all digitally stored and comprised of zeros and ones. Please remember that data is a plural term. The singular term for data is datum. The concept of big data is nothing complex. As the name suggests, big data refers to copious amounts of data, which are too large to be processed and analyzed by traditional tools. Since the amount of big data increases exponentially, more than 500 terabytes of data are uploaded to Facebook's database alone in a single day. It represents a real problem in terms of analysis. So you may be thinking that if this big data is so problematic, then why is everyone so obsessed about it? Well, the answer lies in the benefits it provides. Here are some real-world examples of the ways in which big data is used. Netflix collects user behavior data from its more than 100 million customers. This data helps Netflix in understanding what every individual customer wants to see. Based on the analysis, it recommends movies and TV shows which the viewer will love to watch. As a result, the customer is happy because he is getting what he likes without even searching for it. And Netflix is happy because it has delighted its customers, which will result in higher customer retention. Credit card companies collect and store the real-time data of when and where the credit cards are being swiped. This data helps them in thwarting fraud detection. Suppose a credit card is used at location A for the first time. Then, after 2 hours, the same card is being used at location B, which is 5,000 kilometers away from location A. Now, it is practically impossible for a person to travel 5,000 kilometers in 2 hours, and hence it becomes clear that someone is trying to fool the system. These were just two examples. Big data has hundreds of different applications in hundreds of different fields, be it banking, communication, healthcare, media, advertising, manufacturing, transportation, and retail. Big data can be used everywhere, and this is why more and more businesses are trying to harness its power. Classification is essential for the study of any subject. So big data is widely classified into three main types, which are structured, unstructured, and semi-structured data. Structured data. Structured data is used to refer to the data which is already stored in databases in an ordered manner. It accounts for about 20% of the total existing data and is used the most in programming and computer-related activities. There are two sources of structured data: machines and humans. All the data received from sensors, web logs, and financial systems are classified under machine-generated data. These include medical devices, GPS data, data of usage statistics captured by servers and applications, and the huge amount of data that usually move through trading platforms, to name a few. Human-generated structured data mainly includes all the data that humans input into computers, such as names and other personal details. When a person clicks a link on the internet or even makes a move in a game, data is created. This can be used by companies to figure out their customers' behavior and make the appropriate business decisions and modifications. Unstructured data. While structured data resides in the traditional row-column databases, unstructured data is the opposite. They have no clear format in storage. The rest of the data created, about 80% of the total, account for unstructured big data. Most of the data a person encounters belong to this category, and until recently, there was not much to do except storing it or analyzing it manually. Unstructured data is also classified based on its source, machine-generated or human-generated.
Machine-generated data accounts for all the satellite images, the scientific data from various experiments, and radar data captured by various facets of technology. Human-generated unstructured data is found in abundance across the internet, since it includes social media data, mobile data, and website content. This means that the pictures we upload to Facebook or Instagram handle, the videos we watch on YouTube, and even the text messages we send, it all contributes to the gigantic heap that is unstructured data. Semi-structured data. The line between unstructured data and semi-structured data has always been unclear, since most of the semi-structured data appear to be unstructured at a glance. Information that is not in the traditional database format as structured data, but contains some organizational properties which make it easier to process, are included in the semi-structured data. For example, no SQL documents are considered to be semi-structured, since they contain keywords that can be used to process the document easily. Big data analysis has been found to have definitive business value, and its analysis and processing can help a company achieve cost reductions and dynamic growth. So it is imperative that you do not wait too long to exploit the potential of this excellent business opportunity. This was all about big data and the types of big data. Don't forget to subscribe to Knowledge Hut for more such informational videos.
Okay, so I think that's it for a video presentation. So this time, uh, what you're going to do, of course, is to write your learnings on the video presented, write a summary per presenters, and please prepare for our recitation next meeting. So again, I'll repeat, no, on the provided video, note what you've learned, summarize the presenter's remarks or discussions, and please get ready for our next meeting's recitations. Thank you for attending our class. Stay safe and God bless everyone.